Right, so we've got something different here. My friend Mark, G7NDJ, he came the other weekend. He brought a Jesan KT003. I don't remember seeing one of these, but I'm sure if I look in my back catalogue, we've actually had one. Yeah, right. And you know what? I don't recall knowing anything about these. 3-channel, it's going to be crystal controlled. I've totally forgotten about them. It's got an earphone socket, so at least we can plug the cyanide meter in, and it works off a 9-volt battery. Not sure I can get that out again. Really, it should be the other way on, so that the connector is that way. That's the usual way. Perhaps if we open it up, no, I don't think we're going to be able to open it up with the battery in it. Okay, let's see if we can force the battery out. There we go. So it looks like it's supposed to have 2 screws there, but it hasn't. Does it have something under the belt clip? Am I about to break the belt clip? No and no. It probably slots in at the top. It does. And it says Jonathan Bush inside. Hello, Jonathan. RC 3000 FM. There's RCH as in LCL. So we're not looking at the components, of course, are we? So I think what we're going to end up doing is taking a photograph of the other side, because you're expected to tune it through the holes in the printed circuit. So I can see where they're going with this. We're not going to get a proper power reading unless we remove the loading coil. If it was my set, I'd remove the loading coil. We'll have to go that side and get some kind of wishy-washy power reading. It's probably only 50 milliwatts. Obviously we can't do an on-the-air test, but we will do a field test, which send Mr. Chippie with the body cam up the road, and if it works up the road, I'll get him to go across the road. And if it works across the road, we'll get him to go to Ancaster Crossroads. I don't think it's going to work beyond that. I don't think we're going to use much petrol. But then you've got the realistic TRC 1003, which is 50 milliwatts, and we've had 3 miles on one of those. I hasten to say in good terrain, not the kind of test we do in bad terrain. So one of the screws mounting pillars, I'm not going to be looking for screws. If Mark wants to put screws in, he can, but I'm here to service it. Can we see another screw? We can. What I'm going to do is take a photograph of the board, and then we can see where we are with it. So we have to take these knob extensions off. I don't know whether we've got to unscrew some extensions. Oh. Well, Mr. Tango, it looks like we do. Who'd have thought that? Hey! So we've got an electret mic. I wasn't expecting that. I thought the speaker would be kind of dual use. So it's crystal control, as we can see, and it's got what as an FM chip? KA396T, and then you've got a quarter watt audio amplifier there, LM3A6, and surprisingly it's a JRC, as in Japan Radio Corporation, or Japan Radio Company, whatever they are. So you wouldn't expect there's got to be a frequency adjust for the transmitter for it to be legal, because you've got to kind of take an average of the crystals, haven't you, because they haven't got individual adjustments. So very difficult, because you just do not know. So I'm going to take a photo. We'll pause the video. I'm going to take a photo and just see if we can find an RC3000, perhaps in another region of the world, and find a schematic for that other region set. Okay, so I've had a good search online, and there's nothing on the KT003. If anyone's got an instruction book, especially if there's a circuit, I would be very pleased to have a scan of that. So I then looked up RC3000 FM, and nothing came up for that either. Right, so there's our photos. So how I see it, I'm just, that's going to be frequency, probably for transmit. I'm expecting that to be receive, I'm expecting those to be transmit. How's deviation done? Don't tell me there's no deviation preset. Let's see what holes we've got here. We've got the chip there, we've got that, we're that way around, aren't we? Kind of mirror of that. So that's that, that's that, that's that. Oh, some of these holes are for the screws, aren't they? So that's a coil. That's a coil. And that's a hole. Check there's nothing on the top panel. No. Another version would have some extra parts there. No, there's no presets, folks. Oh yeah, I missed that coil, haven't I? So if we look at the numbers, L1, L2, L6, L5, L7, and what's this one down here? Wax is in the way. Right. Well, it's going to be totally I guess. So can those be adjusted from the other side? Surely not. No. No, so we've got to do something with it from this side. Right, we'll get the crocodile clip leads and we'll make sure the power supply is on 9 volts. Never see which way round these are. It's positives, that one. Power on. Now this is fun without the knob extensions. See, we're going to have to put those back. You know, we wouldn't accept anything like this in for service. I mean, Mark's a friend. But can you imagine how much time this takes? And how much this type of product is worth? I mean, people laugh at me doing fidelity thousands, but I get paid for them, don't I? People think that, you know, radios that were only 20 quid each, new, they're going to cost more than that to service. You know, they seem to think it's going to be on a sliding scale. If you have a £20 radio, it's only going to cost 2 quid to fix. But it doesn't work like that. Dirty volume control, that's doable. If that squells, I'm not typing it on, am I? Well, if that's supposed to be squelched, it ain't doing anything. I think we'll have to make up some adapter or something and come back to this tomorrow. So we'll call it a day for today. I think we've gone beyond 8 o'clock. Okay, so we're back with this. It's such a small signal, I can't read it on the Marconi test tape. We'll it straight into the spectrum analyzer with no attenuators. It's probably about 50 milliwatts. Now, the spectrum analyzer reads in dBm, so I'm going to have to use a conversion chart because my training is all in microvolts, seeing as I'm from the 1970s and 80s. Let's just key up. So there we have it. Sorry, you're not going to. Have we got picture in picture on? No. Glare is not good. I can't really move the analyzer. So we've got a. I don't know whether you can see that. We've got a peak, and it says it's 27782645. So one would think that's supposed to be channel 19. And that's in the channel 2 position of the radio. So if we can see work out the other channels, I could just scan with my walkie-talkie, couldn't I? Be much easier. So just move the spectrum analyzers, trace what we got. I'll tell you what, I'll compress auto peak. 27890978. So 89, it's supposed to be 89125, isn't it? 27899125. 7812589. It's channel 30, isn't it, that? And then the other channel, let's hope it's not 9. Key it up, press auto peak. 27729. So it's going to be 73125, it's supposed to be. Is that channel 14? So we may as well do what we're doing on channel 19, which is the peak of its, at the centre of its band. So if I can get the thing to do more than what I believe to be about 100 milliwatts, we might be able to get a reading. That's my earth gone. So I've removed the loading coil. And you know, it's just, you couldn't do this for a customer. It's just beyond the call of duty. So what's transmit? Well, I think these two are transmit, but I could be totally wrong. Try and do them from this side. That's done absolutely nothing. So one would expect that this is going to do totally nothing as well. No. So they must be receive. But you wouldn't expect those types to be transmit. The frequency. Yes, Mr. Chippie. I just remembered there's another coil which we spotted. This surely can't be frequency. See, the thing is, it's reading half. Here's your problem, isn't it? What to do? Well, I'll rack my brain and get back to you. Okay, so I've got it on the dummy load, and I've brought out the RF voltmeter. It's such a tiny signal that apart from the spectrum analyzer, I can't read it on anything. So, keeping that connected, here comes the next problem. How do I... Oh, because I put that probe through. I put that link I put through the where I took the loading coil from. I took it a pin right the way through so we could measure it. I'm going to do a project on a RF voltmeter because it's a it's a bit like cyanide meters. It's something people don't have. It was January 1974. I think it was Fred Judd did a bit of a signal generator tracer type of project in Practical Wireless, January 74, and part of it is an RF probe. So if we build that RF probe, I mean, there's only half a dozen components. Build it in a cigar tube. Do you remember cigar tubes when they were aluminium? My grandfather, who was born in 1890, used to get cigars. I know that they can be got off eBay, but it makes a metal case and the right shape. So if we can, we've got my walkie-talkie on monitoring. If I can kind of peek those with that. But the Marconi test set can't read that. Well, we're going to do the opposite. I mean, that's the biggest peak I can get, whatever that is. Theoretically, it's 1.5. We're on the what we are? Oh, we're on the 1 scale. Theoretically, it's 0.6 of a volt, but I don't have a nomograph to turn that into power. So, right, let's put that on the. We're on channel 30. We've swapped to channel 30 or whatever it is. Yeah, it is channel 30. 27.89125. So put that in the signal generator. I mean, there's some pretty serious cheap walkie-talkies, but I don't think this is one of them. You know, those Amstrad HCB ones, you know, they do 250 milliwatts or something like that. You get a mile and a bit on them. Okay, so we should be able to plug this into the test equipment through the extension speaker socket, which this does have. Doesn't like that. Let's try putting the stereo adapter in case it's one of those. You know, we can't connect an earth, can we? So it's going to be the crocodile clip. So it's got the speaker socket, but we can't use it. We can't use the test gear. It shorts it out. That's 100 microvolts. Just going to have to do this by ear, like some Wally. That's peak. That's peak. Take the signal down. So is this receive frequency? What we'll do, we'll get the second signal generator. I mean, we're looking at 50 microvolts. You know, we're looking massive signal. So we're going to want this on 455, aren't we? Yes, Mr. Tango, we are. That one. So we'll turn the tone off, put the signal up a bit, turn the tone off. Turn the volume up. I want to know whether we can alter the frequency. And if we can, then it's this one. No. Now this appears to be transmit, but I want to prove it. Yep, that's not affecting it. That's improved the sensitivity. So you can't adjust the frequency. It's not far out. Let's tell you how far out it is. So we've got 89125, as you can see. So let's just turn that. It will have dropped, won't it? I have to reset. So it's receiving at 89058, so it's dropped. So if we go back to 125, it doesn't matter. Right, so you can't adjust the frequency. Let's go back and carry on trying to tune it up by ear. Take the signal down a bit. Or is that the detector? No idea what. I'll tell you what, let's take it off the main supply, put it on battery. Yeah, whatever you do, you short it out. So put a big signal on. That's about 3 microvolts, folks. So I think that's about where we are with it. So that surely must be something to do with the transmitter. Right, go back to transmit. I'll go back into the spectrum analyzer. Go back onto the main supply for the transmitter. Oh, it's worth it. You see how you're clutching at straws on these kind of things. So if we put that back on the thingy and press peak, no, definitely one final thing we can do is to use the oscilloscope. Just see whether we can bring it more on frequency in a real time with this, because we can't get the frequency counter on the Mark only test set to read, as you can see. But digital instruments are not easy to work with, because you've got this lag. $8912, you know. Well, you can't adjust the deviation. Right, what we'll do, put the loading coil back and we'll come back to you. Okay, so I've put that bit of it back together. We'll get our Binatone rather nice trough line type power meter out. You see, you don't expect nice things from cheap makes, do you? But there we are. Binatone had the 5-star, didn't they? And amongst some other products. So we'll use it as a field strength meter. And hopefully, when I key up, we're actually going to get a reading. Now, I mustn't touch the aerial with the aerial. I can't get a reading. So we'll assume that the loading coil is in the correct position. Right, I'll put this back together. Roger, can you take it to channel 30? We'll just do a quick test on this dreadful little handheld. Okay. Tango 21, Mr. Chippie, copy? Okay, talk to me again. Yeah, right, okay. Back to the drawing board with this. Okay, we've had to open this up again because the receive detector's out. So, I'm barking up the wrong tree on this. It looks to me like, apart from the frequency adjustment, I'm just going to loosely couple this. What I thought, if we use this little oscilloscope on battery, drop the signal a bit, or volume. It's not loading this down because it's not. I've got this running on battery, I've got the oscilloscope running on battery, and that is the detector set. Now, there was a small peak on one of these with the transmitter, but it's received. This is received. If I drop down the attenuator, turn the volume up, you'll hear we've got this at peak. We have there. I'll just check to see whether that's transmit. But there we go, I've had to redo it. So we've got these two in the correct position, but these two weren't transmitter, even though one was slightly affecting the transmit. It just looks to me like it just is a crystal oscillator which generates about 10 milliwatts. Let's see what it sounds like. Let's see if we can put the squelch on as well. No, I can't. Turn the volume up. Use my talkie-walkie. Testing 1 2, testing 1 2, testing 1 2 1 2 1 2 1 2 1 2. What happens if we put it on 31? Testing 1 2, testing 1 2. What happens if we put it on 29? Testing 1 2. Yeah, it's got good selectivity, hasn't it? Right, so we have got the detector. It's that coil. So just need to recheck transmit. Once again, I'm going to just meter it on the aerial. I better pull the aerial up. And we're going to have SWR problems. This is session 3, you know, on this. It would help if we had a squirky diagram. It's all guesswork. So I'm just going to probe this, press transmit, and just see whether we've got any difference. This is fun. I've got to press that, and then adjust this at the same time. Yeah. That is transmit. We'd already determined that was transmit frequency. That's transmit power. So that's all there is. So the rest of it is, so we've got transmit frequency, but it's all we've been able to do is to set channel 30 for the nearest possible. with that coil, and then we determined that there was no adjustment for the receive frequency. It's totally controlled by the tolerance and wear of the crystals. So we've got transmit power, transmit frequency, we've got FM detector for receive, and then we've got it's going to be 455 IF, which I presume that is, and those will be the front end, which we've done. And we're not going to touch the loading coil because the thing's giving out so little power that we can't get a sensible reading on any of our meters other than using the RF voltmeter. So there we go. Right, I think we're as done as we're going to be. So let's just I've tried talking to Mr. Chippie on this yesterday from one room to the other. Let's just see whether it comes through. Testing 1 2. Yeah, it does. So this has got to be one of the most dire ones. At least we've got to the bottom of it. It's such a faff to put back together. And I've also realised what all this is about. It's once had battery clips, but they've broken, so somebody's put in a PP3 clip like this. So that's why all this wiring is a faff and a mess. But that's how we've overcome it, by having to use battery operated test equipment, the signal generator loosely coupled, and it's got sensitivity of somewhere around 3 microvolts, but for what quality is another matter. Better take that knob off. It was an absolute faff to put back together. So will Mr. Chippie be able to get out of the car park when we do the test? You just think, what are all this effort in all these parts in manufacturing something like this, and it's such awful quality. I mean, those Harvard 020s, they were $24.99 each, or a pack of 2 for $39.99 at the time. At least they do 200 milliwatts sometimes. But the capacitors in those have all dried up, and they're double-sided boards. You know you can't be changing parts. I've done one. I charged them a token £6.50 for about 7 hours work. You can't carry on doing that. So never again. So you kind of have got to get this so far, and then you've got to feed in the PTT switch. And try and lay it in the bottom section. Something like that. Whilst, oh, there we go. It's come out. Whilst hooking that in there, then it's meant to have screws in the bottom, but this one hasn't. I think we're putting a large elastic band around this. I've got the diagrams on top of the microphones. That then glues on. And that crams in there. And somebody's put, Brian Boss 1970 has put 14, 19 and 30. So I got that right. And we've got to put the knobs back on. I've dropped the other one of these on the floor, so I will just have to recover that. I think that's screwed in now. I have sprayed the controls. Oh, there we go. Actually found it. Okay, well, there's a lot, doesn't it? Is it a Duff potentiometer? Testing 1 2, testing 1 2. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. There we go. One dreadful handheld. That's probably the worst one of all time. It could be as bad as the Chiser. So back to this. We finally came to the conclusion that you've got no receive adjustment on the crystal frequency, but it was within tolerance on the channel we were using, which is 30, and the transmit we've got there as the frequency adjustment, and this as the transmitter's only adjustment for power. We came to the conclusion this was the detector. That's going to be the IF, which is 455 kilohertz, and then we've got the two front end ones. I managed to get about 3 microvolts out of it, and then that would be the antenna loading coil, but it's such a low output, could be 10 milliwatts, that apart from using our RF voltmeter, we can't determine what the power is. So there we are. I could have put it into the once again into the spectrum analyzer, bypassing that, but I'm not going to start unsoldering things again just to on something which is pointless. Somebody might have an instruction book, and that would be really, really handy. I'll just put a rubber band around this for now. I don't want to put screws through. It's Mark's bit of fun set. This got it at a rally for a couple of quid, and you know, on the face of it, it did work, and it still does work. But we've been through it, and there you go. Don't go rushing out buying them. Thanks for watching.